Good afternoon and welcome to Science Review with Mr. Blades. Today we're going to be talking about graphing motion. So let's get started. How are these three graphs different? From first glance, they aren't. But if we add in our x-axis, which is time in seconds, and our y-axis, which in the first one is position, then velocity, then acceleration, we can see that each of these graphs tells us something different. Position is the description of where we are from the reference point. It is denoted with the symbol x and is measured in units of meters. Our reference point, which is shown by the 0 on the graph, is the fixed point where we can choose so that we can define or describe our motion. Now, that is also known as the origin point. What does the y-intercept graph on this graph represent? The y-intercept on this graph represents where we in fact started in relation to the reference point or the origin. 0 being the origin. In this graph we started at 2. We started at 2 boxes away from the origin. Now what is the distance and displacement after 3 seconds? Now we've talked about it before, and distance is how far you travel from the time you started. Displacement is how far you are from the origin. So from 0 to 3 seconds, you can see that we move from 2 boxes to 4 boxes. Now, in distance, that distance from 2 to 4 boxes is just 2 more boxes. But our displacement is actually 4 boxes because we're 4 boxes away from 0. And what is the distance and displacement after 5 seconds? After 5 seconds, you can see that it hasn't changed any since 3 seconds. So both of those answers would remain the same, 2 in distance and 4 in displacement. Now from earlier this week, you might remember that distance and displacement are different. Distance is the total amount of travel no matter which direction. It is a scalar symbolized by the letter D and measured in meters. Displacement is the amount of travel from the origin point. The amount of travel from the starting point, a vector, which means it includes direction. Its symbol is x, or maybe delta x, meaning change in position, and it's again measured in meters. You can see we have 2 spots, both of those little purple circles, and if we were to measure distance, it would be everywhere we went between those 2 circles. But if we were looking for displacement, it'd be the shortest, straightest distance between those 2 things, because that's just how far we ended up moving. Velocity, the speed of an object in a specific direction. So velocity is a vector, speed is a scalar. Velocity is shown by the symbol v and is measured in meters per second. Length divided by time. So if we use dimensional analysis, we've talked about it in school before, that by looking at the units, we can figure out what the equation to find velocity is. If we have meters divided by seconds, we know that we're going to have some sort of length divided by some period of time. So if we have displacement divided by time, delta x divided by t. And that will give us a number of meters per a number of seconds. And that's how we get that equation. The average velocity is different from just an average. We take the total amount of displacement and divide it by the total amount of time. So let's do a practice problem. If we drive our car for 1 hour at 40 miles per hour and then 2 hours at 60 miles per hour, assume that you've only gone in a straight line. What is our average velocity? Well, first we have to figure out how far we've gone. And we do that by saying 1 hour driven at 40 miles per hour plus 2 hours at 60 miles per hour gives us 160 miles. Our total time is 1 hour plus 2 hours, or 3 hours. And our average velocity is going to be that 160 miles divided by 3 hours, which gives us 53.33 miles per hour. Now, we can also figure out our velocity just from looking at a graph. Well, let's take a look at a position versus time graph and answer these questions. What is the significance of the slope in a position versus time graph? Now, you probably remember from math class that the slope is rise over run. And the rise is your change in y divided by the run, which is your change in x. So y divided by x. Our y in a position versus time graph is position in meters. And then our x is time measured in seconds. So if we just calculate the slope, the slope will be in units of meters per second, or a velocity. So the significance of the slope in a position versus time graph is that it tells us the velocity over that period. What is the significance of the y-intercept in a position versus time graph? We discussed that already. That is where we started in relation to the origin point. But now if we take a look at a velocity versus time graph, let's ask pretty much the same questions and analyze. What is the significance of the y-intercept in a velocity versus time graph? Well, just like with position where it tells us our starting point, the y-intercept in a velocity versus time graph tells us our starting velocity. But let's take a look at the graph and see what happens after 6 seconds. At 6 seconds, we have a velocity of 4, and then we see that it sharply dips down. Now, because the slope on a position versus time graph shows us velocity, the slope on a velocity versus time graph shows us acceleration. So we can see that the velocity on our velocity versus time graph starts at 4 and then heads towards 0 and then becomes negative. Now what this means in a velocity versus time graph is that the velocity slows down, briefly touches 0 as it crosses the x-axis, and then becomes negative, which means that its velocity pointed in the opposite direction. So that's what we can tell just from looking at one of these graphs. I hope this was very helpful. Please ask me any questions you have in class, leave comments, and like and subscribe, and I'll see you in class.